Right Machine Works. My name is Keith, and today we're going to get in here. We're in on the PlasmaCAM, and we've drawn up a what we want to try for a pattern for our tracer attachment to turn the contour on these pulleys that we're doing for vintage machinery. Keith Rucker sent this project up here, and we're going to get it knocked out and get it on its way back down to him so he can finish putting the machine together. Now I'm going to go ahead and I'm going to bring you in here a little bit, and we're going to take a look at the pattern and thing. I'm not going to really show you how I drew this up, but I want to show you a few features. Alright, the dark purple here you see is a silhouette of the actual part, and the blue line on the outside is actually the cut path. Now the cut path also shows you the width of the cut, and I'm going to pinpoint you in here. We're going to zoom in to the pierce point right here. After it pierces, it travels in and it goes around the part. Okay, now this width right here is actually showing you the kerf width. So we take our measurement from here across to here, roughly. Distance is 80 thousandths of an inch. Alright, that's what we have it programmed right now for 80 thousandths. We're running 60 amp tip here, and I think we're going about 80 inches a minute. Seem to be doing pretty good. It leaves a little bit of slow dross on the other side, but it leaves a really good edge on the part, and that's what we're shooting for, because it's going to be a tracer pattern. We could probably even slow it down a little bit more, but for the most part, I think it'll do fine. Alright, now I brought this up here, and what we're going to do is, here's the cut preview, and it'll come and it'll do the two holes and go around the outside of the part. Now another feature here, at the end of the part here, of course I have it in there pretty close, but this distance that you have in here, you can lengthen that out to where it stops back here, and there's a little bit of a solid tab sticking here so the part can stay in without falling through on the table. Just a couple quick points there of what I got going on the program or table here. All right, let's go ahead and we're going to turn on our power here for cut and get some ventilation here. We're going to cut out a first one here. We're going to see if we have a good pattern for this. And we're going to, after we cut out this piece here that we want to try in there, we're going to take and we're going to draw a little shape around the top side of our cutaway, and we're going to use it as a female to test on our pulley here. There's our pattern. Pretty good side finish. Very little dross. Actually almost flicks off with your fingernail. Or like they say, if you drop it real hard, you know, it does. It just comes off real easy. Alright, let's get this cleaned up and we're going to check it out. Okay, here we're going to make a reverse cutout. Making a U-shaped cut. Okay, now this will give us the negative of the pattern. This should be able to test right on the pulley. We got both of our pulleys here, and we're going to be setting up, and we're going to be doing this one here first But this one here has a smaller bore and it fits to this shaft here, 1 7/16. So we kind of were able to slide it on real quick just to go ahead and locate our pattern here. I do want to loosen this up a little bit and set it square so that I know that that curve and that arc is square to the pattern and the setup here in the lathe. Okay, our stylus will be able to come in, touch here, and go over and come create that radius in here and the radius over here and this large radius here. So there really isn't any square or straight lines except for the back face here, which is already done, and this bore and this face in here, which is already done. So my job is just basically to kiss this face off the length and take care of this contour on the outside. Now I got another piece of shaft and we're going to go ahead and set that up in here, and I'm going to turn the diameter to handle the first one, and then we'll machine it and we slide it off, and then we'll go ahead and we'll take down to the next diameter, which will fit this one here, and it would be just a couple thousandths over the nominal there. It's not extremely loose on there, but I would like it to be tighter for my operation. So my job is to turn the OD concentric with the ID, and that's what I plan on doing. Alright, so we're going to get this out, and I pretty much want to have this length here. So we're going to measure that length, and on this dummy piece of shaft here, we're going to go ahead and create the same. Never find a Sharpie when you want one. Okay, same distance out, be right there, and we'll put a center drill hole in there, and we're also going to be putting in a little bit of a relief right here so we can turn this diameter and not worry about coming up to our chuck face. But the back side of our pulleys that are already finished will be sitting against that face right there. Both of them have a set screw, both of them are in the same position, and I'm going to be putting a small flat in that position. So there's a couple things that I got to do to get this ready to go. And that's all it's going to need is a set screw tensioning to do all of this turning. Alright, we bring this down, we're going to touch, we're just putting a flat in for that set screw. Here's where the chuck is going to be, and this distance out here is just kind of giving plenty of room out here. We set a depth there, and we're going to go ahead and we're going to come down, we can come down 100 thousandths, alright? And we're going to give it some speed here, and we're going to answer that phone. We're back again. Alright, and we didn't actually get our belt tightened. Okay. Now this is no race or anything, so I don't think we're going to bother putting any coolant or anything else on it. Just mild steel here. Coming back here because we're going to go ahead and we're going to walk it down here. Think of this a little flat, and even after we turn this diameter right here, we'll still have a flat to put the set screw against. Okay, we're going to put it in the lathe, set it up, and we're going to go ahead and relieve an area right in here, just in front of the chuck, and then we're going to slip this in the right position, center drill it, do our first turning, and set up on our first part. We got this sticking out from the jaws there, and that's basically where we want to be. Now we're going to put a little undercut in here, and we only need to go 1/8 of an inch or so per side in and out. So we're just we're going to do this whittling it by hand. Okay, just kind of a little radius there. Now we're just gonna bring this in so that about the middle of that radius is flush with the outside here. Now we'll be able to come here and we'll turn this OD. So I'm slightly tensioning it and rotating at the same time. It's kind of a habit I've gotten into, and it really kind of helps center your part. And I'm happy the run out looks minimal. We're going to put a center drill here, and then we're going to be supporting it with our center, and we're going to be doing our turning. And it's like a number 4 center drill. Boy, I'm so glad I got that back on the left-hand thread there. I know I keep saying that, but I went shoot, what I must have went a couple months at least before I got that changed around. Alright, now we'll just adjust the cut here. Alright, we're going to touch off and take, we know that we're going to be, and I think we're going to go ahead and we're going to play around with our new Pittsburghs today. And it's reading like 1502, and if we're 38.15 millimeters. All right. I'm just taking 10,000ths off of this so we get a diameter. We'll play around with what we got here. Now we're only going to need about that much right there. Part of that a column on the inside. All right, and we need some feed. We set our pulley up here, and this is going to be our first one. This is the one that we have the largest bore, and we're just taking a snap gauge. We want our arbor that we're going to drive these to make the OD run perfectly true with the ID, and we get 1 inch 456, 1 inch 452, somewhere in there. So a couple thousandths over 1/450, and I mean we checked these with our Pittsburghs there, and they were measuring 180 or 481. I got 480 with this. Excuse me, 482 here. Probably 481 in the middle here. You know, thereabouts. It's actually a little bit smaller in the middle than it is out the end. Alright, so we got a little bit less than 30,000 to take off of here. And we're going to go ahead and we're going to take another 10. That'll be 20, and that'll leave us somewhere around the 9,000ths or so total to take off of here. go ahead and we're just going to call that 15. We're measuring up the bore at 52 or so, 51, 52. So we're going to go ahead and take 6 aside here, somewhere around the 12 thousandths mark there. That'll leave us a little bit. This is semi smooth finish here. Should be able to massage it with some paper and get it right down to the finish size. This is just cold roll, so it's a little terry. And I don't like running this big machine up in the RPMs up at the top in there, because it's got straight spur gear teeth, and it howls like the big dog, and I don't feel like listening to it, so that's kind of why I go this other route. Alright, so there's 6, that would be 12. Alright, and 1/454, 1/454, and we're gonna pretty close to the same finish here. We're just gonna check this out here. 1 inch 454. 1 inch 453 I got there. I might have been just a little bit tight there. What do we got? Yeah, 1 inch 453. 1 inch 453. Alright, I'm going to get cloth to fit in here, and I'm going to go ahead and polish this up a little bit until I get this to fit on here. I want to go ahead and I want to break that leading edge there. Okay. .452 and 2/10 or so. 452, 451, 451 and 8/10 or so. 451 and a couple tenths. So we're pretty close to being right down there. I'm going to take a couple more strokes off of there because I'm not afraid to have 1/2000 clearance in there. And I'm going to change up on files here. grit. Some really good paper here, aluminum oxide. It's made by 3M, made in Canada. Very, very durable. I buy a big bulk of this, and I think I'm on my second year now, and I fold them in half, and I usually polish by hand, but this is fast removal and very nice general purpose paper to polish in the lathe. I'm at 1,451 and a half, 151, 151. All right, that part should slide right on here now and no problem. And we'll go ahead and clear off our catcher just so we don't get grit and grind on our ways. It's very, very important to treat your machinery with respect there. Of course, some people don't like how I lay tools on my working surfaces, but I don't mess around with the ways at all. Okay, now pretty close. It's still a little bit warm. But we can probably get another thousands off of there. We'll work this diameter down until we get that to fit on. Alright, we had just a little bit of taper inside the bore, so we took another light skim on here, and she slides on here. I'm staring down at the flat there. Well, I'm gonna have to tap that down in there through the key there, or slip a piece of 5/16 rod in there. I think I'm gonna slip a piece of 5/16 rod down in there, probably yo long, so that it'll go down and rest against that flat. Alright, I found a piece of 5/16 silicone bronze. Some really tough, strong bronze. But it's perfect for this application. I'll slide it down in there, and then that will push against the flat down there, and this set screw should be still far enough down below the surface, and we'll keep an eye on it if need be. We can, oh, it's going to be plenty. Alright, so now we get it locked on that flat, and we get this against the chuck there. Once we get this one cut and shaped, the pattern's going to be perfect for the next one in here. So we're going to do all of our adjustments on this one here, and then when we get done with this, then we'll pull this off, skim this down to the next size, which is slightly smaller than this one, and then we'll go ahead and turn its OD. Alright, now we're going to focus on our pattern down below. Okay, we're setting up our pattern down there to our part here, and we're going to probably, we're real close now. We got it bolted down there, and we can follow this around as it comes around, and then as it comes up, and then around to the top there. It touches in this area right here, but when we 180 this thing on over here, it starts out close here, comes around, and then comes around the end there. Fine. Okay. But I want you to go ahead and I want you to look at how this part runs out here. So that's why one side of this seem like to be real close in the clearance over here and not over here. And the same with this coming in and out over here. So we're going to start it out real slow. We're going to come in until we touch in one part of the travel or the other, and then come on across and make the whole pass, and then come in with increments. And then if we need to advance forward or back, we can adjust that with our pattern in between the centers, and that's how it works. So I'm just slowly rolling this by hand. There's a lot of airspace right there. Coming out on that base, coming around the outside. For first placement, that's not bad. We're going to check this diameter here. We're going to be checking all the dimensions to our drawing right here, making sure that we don't exceed any of them, remove any more than what we need on here for the part. But basically, this is a contoured shape so that it'll drive the belt, and that's what this is all about. It's not a high precision item, but we want to have two uniform, nice, clean pulleys, as close to the drawing as possible. And we just started clipping on this side here. We've got almost a full turn around here. The major depth from here up to here is like 7/8 when it's finished, and right now we're about 15/16. Alright, now that we stopped touching there, I'm going to go ahead and bring it around here until we start touching again. Now this middle here is supposed to be like 4 1/4 roughly, and they got to both be at least the same. All right, I'm going to engage the feed right there. Before we spread too much more cast iron, I'm going to go ahead and lay a rag in here before our next pass. Well, one good thing is our shape is pretty close to the casting shape as well. So we're starting to skip right on down in here. We're getting close to this right here. This is a high spot here. We're actually starting to hit here. So we've got quite a ways to go. Let's just hope that this radius here, they asked for 8.5 inch radius, and I know we got that. With that to see how close it actually comes out to be. All right, a little back